According to National Electrical Code Section 250.92b, for raceways carrying over 250 volts, bonding is required at both ends of the raceway. The code states that bonding shall be provided between metallic raceways, boxes, cabinets, and fittings by means of equipment bonding jumpers, bonding bushings, and other approved means. Exception 250.97 allows for bonding on only one end of the raceway if the raceway is terminated to grounding electrode as described in 250.52a or refer, such as a transformer grounding electrode, isolating enclosure, or a grounded feeder enclosure. Now let's look at an example. In a scenario where you have a piece of metal-clad cable running from a panel with ringed knockouts to a box with knockouts listed for grounding, the raceway is not terminated at a grounding electrode, as described in exception 250.97 Therefore, both ends of the raceway require bonding. At the panel end, a bonding bushing must be installed on the panel end to bond the raceway to the panel enclosure. The box with knockouts listed for grounding provides assured bonding for the raceway on that end. Installing a ground wire for 480/277 volt circuits is not a violation. In fact, National Electrical Code Section 250.122 requires a ground wire for all conductors in alternating current circuits over 1000 volts between conductors. However, a ground wire is not a substitute for proper bonding of the raceway. Therefore, in the scenario, you would need to install a bonding bushing on the panel end of the metal-clad cable to ensure proper bonding of the raceway. It is important to follow National Electrical Code requirements for bonding to ensure electrical safety and compliance. The purpose of bonding is to create a low impedance path for fault current to return to the source. This low impedance path allows overcurrent protective devices, such as circuit breakers or fuses, to quickly and effectively clear a fault, minimizing the risk of electrical shock and fire. Without proper bonding, fault current may flow through unintended paths such as built-in steel or metallic piping, which can create dangerous voltage potentials and increase the risk of electrical hazards. Bonding is particularly important in systems operating at voltages above 250 volts, as the potential for dangerous fault currents is higher. The National Electrical Code provides specific requirements for bonding in these systems to ensure that the electrical system is safe and reliable. When dealing with metallic raceways, such as conduit or metal-clad cable, bonding is typically accomplished by using bonding bushings, bonding jumpers, or other approved means to connect the raceway to ground. Bonding bushings are installed on the end of the raceway and provide a secure connection to the enclosure or equipment being fed. Bonding jumpers are used to connect sections of raceway together or to connect the raceway to other grounded metal parts. The selection of the appropriate bonding method will depend on the specific application and the requirements of the National Electrical Code. In addition to bonding the raceway, it is also important to bond any metallic boxes or enclosures that are used in the electrical system. This can be accomplished by using listed grounding knockouts, which provide a direct connection to the grounded metal of the box or enclosure. Alternatively, bonding jumpers can be used to connect the box or enclosure to the raceway or other grounded metal parts. It is important to ensure that all bonding connections are properly made and are tight and secure. Loose or corroded connections can increase the impedance of the bonding path and reduce its effectiveness. Regular inspection and maintenance of bonding connections are essential to ensure that the electrical system remains safe and reliable. When installing a ground wire in an electrical circuit, it is important to select the appropriate size wire for the application. The size of the ground wire is typically based on the size of the ungrounded conductors in the circuit, as specified in National Electrical Code Section 250.122. The ground wire must be properly connected to the grounding electrode system, which provides a direct connection to the earth. The grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode. The connection to the grounding electrode system must be made in accordance with the National Electrical Code and must be accessible for inspection and testing. In addition to the requirements for bonding and grounding, the National Electrical Code also provides specific requirements for the installation of electrical equipment and wiring in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. In these locations, special equipment and wiring methods must be used to minimize the risk of ignition. The National Electrical Code classifies hazardous locations into different classes and divisions based on the type of hazard present and the likelihood of its occurrence. Each class and division has specific requirements for the type of equipment and wiring that can be used. It is important to consult the National Electrical Code and other applicable standards to ensure that electrical equipment and wiring in hazardous locations are installed in accordance with all applicable requirements. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical safety. It is important for electricians and other electrical professionals to be familiar with the National Electrical Code and to follow its requirements when installing and maintaining electrical systems. Failure to comply with the National Electrical Code can result in serious electrical hazards, including electrical shock, fire, and explosion. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed depending on the location and type of electrical system. These codes and standards may include local building codes, state electrical codes, and industry standards. It is important to consult with the local authorities and other relevant organizations to determine which codes and standards apply to a particular electrical installation. Proper bonding and grounding are essential for electrical safety and are required by the National Electrical Code. By following the requirements of the National Electrical Code and other applicable standards, you can ensure that electrical systems are installed and maintained in a safe and reliable manner. Remember that even though ground wires are necessary in most circuits, they are not a substitute for proper bonding of metallic raceways and enclosures. Bonding ensures a low impedance path for fault current, allowing overcurrent devices to quickly clear faults and minimize hazards. In your scenario, where you are running metal-clad cable from a panel with ringed knockouts to a box with knockouts listed for grounding, it's crucial to understand the specific requirements. Since the raceway isn't terminated at a grounding electrode, as described in exception 250.97 both ends of the raceway must be bonded. This means you'll need a bonding bushing at the panel end to bond the raceway to the panel enclosure. The box with the listed grounding knockouts will provide the necessary bonding on that end. Neglecting to install the bonding bushing at the panel end would be a violation of the National Electrical Code and could compromise the safety of the electrical system. Always double-check your work and refer to the latest edition of the National Electrical Code to ensure compliance. Staying up to date with code changes and best practices is essential for all electrical professionals. Proper bonding is crucial for electrical safety and ensures that fault currents can safely return to the source, minimizing the risk of electrical shock and fire. Always follow National Electrical Code requirements and use approved bonding methods to ensure a safe and compliant installation. Also, consider the specific requirements for bonding when using flexible metal conduit or liquid-tight flexible metal conduit. These types of raceways may require additional bonding measures to ensure a continuous lower impedance path for fault current. Always refer to the National Electrical Code for specific requirements related to the type of raceway being used. Consider these points about electrical enclosures. Metal enclosures, such as junction boxes and panel boards, play a vital role in protecting electrical components and providing a safe environment for electrical connections. When working with metal enclosures, it's essential to ensure that they are properly grounded and bonded to prevent electrical shock hazards. Grounding and bonding of metal enclosures provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices to quickly clear faults and minimize the risk of electrical shock. Always follow the National Electrical Code requirements for grounding and bonding of metal enclosures to ensure safe and compliant installation. Remember that proper bonding is not just a matter of code compliance, it's also a matter of safety. By ensuring that all metallic parts of the electrical system are properly bonded, you're creating a safer environment for yourself, other workers, and the public. Take the time to learn the proper bonding techniques and always double-check your work to ensure that all connections are secure and compliant. In addition to the National Electrical Code, there may be other applicable standards and regulations that govern electrical installations in your area. It's important to be aware of these requirements and to follow them when installing and maintaining electrical systems. Local building codes, state electrical codes, and industry standards may all have specific requirements for bonding and grounding. Consulting with local authorities and other relevant organizations can help you ensure that your electrical installations are in compliance with all applicable requirements. Proper bonding and grounding are essential for electrical safety, and it's important to take the time to do it right. By following the National Electrical Code, local regulations, and industry best practices, you can create a safer and more reliable electrical system. Never compromise on safety when it comes to electrical installations. Always double-check your work and seek guidance from qualified professionals when needed. Staying informed and up to date on the latest code changes and best practices is essential for all electrical professionals. Remember that electrical safety is everyone's responsibility, and by working together, we can create a safer environment for all. When working with electrical systems, it's important to be aware of the potential hazards and to take steps to mitigate those risks. Electrical shock, arc flash, and arc blast are all serious hazards that can result in injury or death. Proper bonding and grounding are essential for reducing the risk of these hazards. By providing a low impedance path for fault current to return to the source, bonding and grounding help to ensure that overcurrent protective devices will quickly clear faults and minimize the duration of exposure to hazardous energy. Always wear appropriate personal protective equipment, such as safety glasses, gloves, and arc-rated clothing when working with electrical systems. Never work on energized equipment unless it is absolutely necessary, and always follow lockout-tagout procedures to ensure that the equipment is energized before beginning work. Remember that electrical safety is not just a matter of code compliance, it's a matter of life and death. Take the time to learn the proper safety procedures and always follow them when working with electrical systems. By working safely, we can protect ourselves and others from the hazards of electricity. Also, consider the importance of regular inspection and maintenance of electrical systems. Over time, electrical connections can loosen, corrode, or become damaged, which can increase the risk of electrical hazards. Regular inspection and maintenance can help to identify and correct these problems before they lead to serious incidents. Perform regular visual inspections of electrical equipment and wiring to look for signs of damage or deterioration. Use a multimeter to test the continuity of bonding connections and to verify that grounding systems are properly connected. Tighten any loose connections and replace any damaged components. Keep electrical equipment clean and free of dust and debris. By performing regular inspection and maintenance, you can help to ensure that electrical systems remain safe and reliable for years to come. In addition to the technical aspects of bonding and grounding, it's also important to consider the human factors that can contribute to electrical accidents. Fatigue, stress, and distractions can all impair judgment and increase the risk of errors. Make sure you are well rested and focused before working with electrical systems. Avoid working under pressure or when you're feeling stressed. Take regular breaks to stay alert and avoid making mistakes. Minimize distractions by turning off your cell phone and avoiding conversations with others while you're working. By being mindful of these human factors, you can reduce the risk of electrical accidents and create a safer work environment. When troubleshooting electrical problems, it's important to use a systematic approach to identify the root cause of the issue. Start by gathering information about the problem, such as when it occurs, what symptoms are present, and what equipment is affected. Use a multimeter to test voltages, currents, and resistances to identify any abnormalities. Consult wiring diagrams and technical manuals to understand the circuit and how it's supposed to function. Follow a logical troubleshooting process, such as starting at the source and working your way down the circuit. By using a systematic approach, you can quickly and efficiently identify the root cause of electrical problems and implement effective solutions. And remember to always prioritize safety when troubleshooting electrical problems. Never work on energized equipment unless it's absolutely necessary, and always follow lockout-tagout procedures to ensure that the equipment is de-energized before beginning work. Wear appropriate personal protective equipment and use insulated tools to protect yourself from electrical shock. Remember that electrical troubleshooting can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Also, be aware of the limitations of your knowledge and skills. If you're not comfortable working on a particular type of electrical equipment or system, it's best to seek guidance from a qualified professional. Never attempt to repair or modify electrical equipment without proper training and experience. Working with electricity can be dangerous, and it's important to know your limits and to seek help when needed. Consider the importance of communication and teamwork when working on electrical projects. Effective communication is essential for ensuring that everyone is on the same page and that the work is being done safely and efficiently. Clearly communicate the scope of the project, the tasks that need to be done, and the potential hazards involved. Use clear and concise language and avoid using jargon or technical terms that others may not understand. Encourage team members to ask questions and to voice any concerns they may have. Work together as a team to identify and mitigate potential hazards. By fostering a culture of open communication and teamwork, you can create a safer and more productive work environment. And finally, remember that electrical safety is a continuous process. It's not something that you can just do once and then forget about. You need to constantly be learning, improving, and adapting to new technologies and best practices. Attend training courses, read industry publications, and stay up to date on the latest code changes. Share your knowledge and experiences with others and learn from their mistakes. By continuously improving your knowledge and skills, you can become a more effective and safer electrical professional. Electrical safety is everyone's responsibility, and by working together, we can create a safer world for all.